Okay, so this lesson that we're going to complete is lesson 6 in your workbook on page 325. It's factoring polynomial expressions part 2. It is exactly like we did in lesson 5 with factoring, except there's going to be one additional concept that we have. So if you want to flip this page and go to page 326, we are going to get to the first example. When we did lesson 5, they were called integral polynomials, and it had a leading coefficient of 1. So in lesson 5, all of the polynomials that you factored had a coefficient of 1. In this lesson, we're going to be factoring polynomials that have a leading coefficient with a number other than 1. And what's going to happen is if you're factoring with an integral coefficient that is not 1, you're going to get one of your factors, at least one, will be in this form here, ax minus b. And what that means, it means that the root of this binomial is going to be a rational number. It's going to be a fraction. So for example, one of your factors could be 2x minus 3. If you get that as a factor, that just means that the root of this binomial will be, there'd be an x-intercept at 3/2. Okay, which is 1.5. So in lesson 5, all of our x-intercepts were integers, and now our x-intercepts could be rational, so they could be decimals. And I will show you how we're going to do that. I'm not going to be concerned when we have a leading coefficient other than 1 for you to give me all of the potential zeros. I don't need that. We're just going to get right into factoring. So what I've done is I've already put this into my calculator for you, and I would, if you want, you could enter it, but I'll show you what it looks like. So here's that equation in here. Don't worry about this. This is just for the next lesson. If I graph this, so if I see a 3 here, this is a third degree polynomial. Remember, it could have up to 3 x-intercepts. So I graph, there is 3 x-intercepts, okay? And if I look at my table of values, second function table, I have one x-intercept right here. So x is equal to 1 as a root. And then if I scroll down, 9 is also a 0, right? So I'm looking for the zeros, which would be the x-intercepts. So going back to my graph, they're giving me this guy, which is x is 1, and they're giving me this guy, which is x is 9, but this guy is not listed, which means it's going to be a rational x-intercept, okay? So here's how we would do this. So I'm just going to write off the side. I know that x is equal to 1 is going to be one of my zeros or one of my roots. And I also know that x is going to be equal to 9. So two of my factors that I know will be x minus 1 is going to be a factor, and x minus 9 will be a factor. But they want me to fully factor this, right? So how would you fully factor this? Remember, you could choose either of these to start with. And I'm going to choose the 1. I'm going to do synthetic division. And I'm going to choose my root of my binomial to be 1 here. Let's put in our coefficients. So 5, negative 51, 55, and negative 9. Carry out your synthetic division. So drop your 5, perform your multiplication. From here, you're going to do your addition. Negative 51 plus 5 is negative 46. Carry out your multiplication, and you'll get negative 46. Then you're going to carry out your addition. And 55 plus negative 46 would give you 9. Carry out your multiplication. You get 9 here. Do your addition, and you get 0. So we wanted the remainder to be 0. And the reason why we wanted the remainder to be 0 is because if you show me that the remainder is 0, then we know that this is a root of the polynomial, which means x minus 1 would be a factor. So let's actually write that out down here. We'll say since r is equal to 0, right? Since the remainder is equal to 0, x is equal to 1, so this guy here, is a 0 of p of x. Because they're asking for, in this example, the zeros. So is a 0 of P of X. Okay, so now let's write where we are with our polynomial and what we factored so far. So P of X is equal to, we know that this was a factor, which is going to be, in order to get a 0 of 1, the factor was x minus 1. So it was, remember, your divisor times your quotient. This here would be my quotient. If this is a third degree polynomial, my quotient is a second degree polynomial. So that would be 5x squared minus 46x, and then plus 9. So here, we're going to factor this quadratic. So remember I said if ever you get a quadratic, you're able to factor this. In lesson 5, you factored by inspection or PSA 1. If you have an A value that is not equal to 1, you are either factoring by PSA 2, if you know that term from if you're in my class earlier, or the decomposition method. So remember that the decomposition method was you're looking for the product of 5 and 9. So you're looking for the product of 45, and you're looking for the sum of negative 46. So it's pretty easy for this one, right? The answer for this would be, what would it be? Negative 1 and negative 45. And then remember, you would decompose this term and get your answer. What I'm going to show you, though, that I actually like doing is if it's a PSA 2 question, because those are sort of longer questions to factor, if you're comfortable factoring by decomposition, do it. You could also factor, though, by synthetic division. So watch what I would do if I wanted to quickly factor this. I'm going to create another upside down division bar, coefficients of 5, negative 46, and 9. I've already used this guy, right? So now I'm going to have to use the 9. Drop your 5, carry out your multiplication, and you'll get 45 here. Do your addition, and you would get negative 1. Carry out your multiplication, and you would get negative 9. After your addition, you get a remainder of 0. So I just proved that 9 is also a 0. This is now my new quotient. It was a second degree polynomial. So this quotient is going to be a first degree, which would be 5x minus 1. And then we had the 9. So the factor that gives you a root or a 0 of 9 would be x minus 9. And then we had this guy. And that would be our polynomial completely factored. Okay, looks like I have an extra bracket. But yeah, that's what the polynomial would be. So what's interesting is I could have actually showed you this in grade 10. I could have showed you synthetic division in grade 10. I debated doing it and then I decided against it. But I will often not do decomposition. I will just set up a synthetic division, even if it's a quadratic, you're able to do that. Okay, so B says that show that x is equal to 1 is a 0. So here's where we showed it, right? We show that x is equal to 1 is a 0 by getting the remainder of 0. And then it says, and hence determine all zeros of P of x. So I didn't quite finish up B. I have to, it wasn't asking for me to factor this. It was asking me to give all the zeros. So I'm just going to write that down here. So the zeros of P of x are, this 0 is a 1, this 0 is a 9, and this 0 is 1/5. Okay, so again, when you have a leading coefficient other than a 1, you're going to have at least one of your binomials will be in the form of ax minus b, and that will always give you a rational 0. C says solve this equation. So solving this equation is just factoring again, right? So what you would do is for this one, if they wanted the equation solved, I'm going to let this equal to 0. So x minus 1, x minus 9, and 5x minus 1. That is equal to 0. So if they want an equation, you always let it equal to 0. And then from here, when you're solving, so that word solve, you are saying what is x equal to. Because remember, solving, you let each x equal to, or each factor, sorry, equal to 0 and solve. So my x-intercepts are what I get from solving, and x is equal to 1, this guy would be 9, and this guy would be 1/5. The exact same answers, except because they're asking me to solve, I have to say x is now equal to. The zeros are the same thing. They're just the x-intercepts as well. Or they could have used the word roots, right? They could have used either of those. So just make sure on a long answer that if they ask solve, let it equal to 0, and you have to put x is equal to. If they ask for the roots or the zeros, you write whatever word that is of p of x, r, and then list them off. That is the lesson for lesson 6. So I will give you your homework. Your homework for lesson 6, there's only 4 questions you're going to do. You're going to do number 2, C and D. Actually, there's only 3 questions, 2, C and D, 3, and 4. One thing I just want to mention with number 2, so let me just show you this guy. When you type this into your calculator to get your zeros, you're only going to see 1 0. So 1 x-intercept, there's going to be 3 x-intercepts, but only one of them you'll be able to get from your table of values. So if you only have 1 x-intercept that you could get from your table of values, you can't do synthetic division twice. So this one, you would have to either do PSA 2, which is decomposition. For the other 2 examples that I wanted you to do, see if you could do synthetic division all the way to the end, like I just did with that class example. Okay, so that, like I said, is lesson 6. Now we're going to move on to lesson 7. So lesson 7 is on page 331 of your workbook. And what's happening with lesson 7? So we're done all of the factoring in polynomials, and now we're moving on to graphing. So lessons 7, 8, 9, and 10, these last 4 lessons are all on graphing. Okay, this is just going to be this part here. It's a review from lesson 5. We'll quickly fill it in. If it's a function, they generally say the zeros of a function. If it's a graph, it's x-intercepts of a graph, and then the equation is the roots. So roots of the equation. These 3 we could use interchangeably. They are always going to be the same numbers. Okay. Let's now go to that very first class example. If you have your calculators, you could enter this into your calculator. So what I'm going to do is I'm just going to get rid of this guy. And I have it entered down here. So I'm going to select that guy. This whole lesson is a calculator lesson. So what it says for this one is it says the zeros, oh, they actually graphed it for us, so we don't even need to graph this one. But it says the graph of P of X is shown. So again, 3rd degree polynomial could have up to 3 x-intercepts. This guy does. Use this graph, so we don't even have to graph it. You could graph it on your calculator to confirm these answers, but it says use this graph to state the zeros of the polynomial. So the zeros of the polynomial, whereas y equal to 0, would be right here at -2, right here at 1, and here at 3. So the zeros of the polynomial, they are -2, 1, and 3. Once you have your zeros or your roots, your x-intercepts, you could go directly into your factors. So if I know the zeros, I could state the factors of the polynomial. So in order to get a 0 of -2, my factor would be x plus 2. In order to get, so that guy's going to be a factor. In order to get a 1, I'm going to have x minus 1 as a factor. And in order to get 3, my third factor and my last factor would be x minus 3. Write the polynomial in factored form. P of x is equal to x plus 2, x minus 1, and x minus 3. Sometimes students will ask, do I want factors written in a certain order? And no, the answer is, if these were the 3 factors, as long as you have them written in any order. Somebody might start, if this was a test question, with x minus 3, right? And then they might do x plus 2, x minus 1, as long as you have the 3 factors. Okay, it says use a graphing calculator to sketch P of x in expanded form and in factored form to verify. So we're actually not going to do this one, because what they want you to do for this one is they want you to, you could do it later on if you want, but if you put this guy into y1, right? So put that guy into y1, you will get this picture here. And then, actually, this would be a really good check on an exam. If you put the factored form into y2, what would happen is the graph would go identically over this y1 graph. If the graph is even slightly off, you factored incorrectly. Okay, so this is actually a really good check to do for your exam. Punch the original into y1, punch what you think is the factored form into y2, and you must get the exact same graph. So that's class example 1. Class example 2. Oh, this is the one I think I had entered in my calculator. Use a graphing calculator to sketch the graph of the following polynomial function. So again, it's a 3rd degree polynomial. It could have up to 3x intercepts. I know that this is my constant term of -10. So there's going to be a y-intercept down here at -10. Take out your calculators and put that in your calculators. Just make sure that that is the one I have in. Yeah, right here. So -x cubed plus 4x squared plus 7x minus 10. When you have that inputted into your calculator, you could hit your graph. So we could look at the graph. Now, we haven't done this up to this point, but I will want you to change your windows so that you could see the picture of the graph more clearly. So for example, I know that there's going to be a minimum down here, right? And I know that there's going to be a maximum up here. So I want to extend my y to go higher than 10 and lower than -10. So I'm going to go to window, and I don't really know what to change it to. I'm just guessing right now. I'm going to do -20 to 20. What I do as a scale factor is if this was like going, if this, I want to go a maximum of 20, I just take off a 0 and I'm going to do a scale factor of 2. That just means that each hatch mark is going up by 2. I could have kept it at 1. Actually, you know what? I will keep it at 1 just so you can see. Okay, so that's pretty good, right? I could go even higher. If I asked you to calculate what this maximum is, I would need to go higher, right? Because if you were asked to calculate that, but this gives me a pretty good like image that now I will know how to sketch this. I can look here and I could say, I think that I'm going to have a 0 at -2, at 1, and at 1, 2, 3, 4, and at 5. To double check, I'm going to look at my table. So it looked like -2, yes. So there they are, my 3 zeros. X is equal to -2. There's a 0 at 1, and then there's a 0 at 5. Okay, so let's write those 3 zeros down. Oh, they're calling it x-intercepts, so that's perfect. The x-intercepts, according to the calculator, -2, 1, and 5. From my x-intercepts, I could get my the polynomial in factored form, because each of these I could write it as the factor. So in factored form, they're calling theirs P of x. I'm going to call my polynomial P of x. The factors to get these corresponding x-intercepts are going to be x plus 2, x minus 1, and x minus 5. They want this sketched, so we're going to sketch this. I'm going to put in my x-intercepts at -2, at 1 and 5. So at -2, there's an x-intercept there. At 1, there's an x-intercept. And at 5, I'm going to look at the picture to help me sketch this more accurately. So for my graph, so what I mean is I know that it's going to fall, like my graph is going to fall here. And then I want my minimum to be lower than 10, right? Because if this is 10, I want the minimum point here to be lower than that. So how I'm going to graph this is as follows. It's not that smooth. Then it has to go through that 0 and that 0. And then I'm going to do this, and I'm going to write -10 is what I would do there. So that you're showing that your y-intercept is at -10, that you're acknowledging that you know that the constant term is the y-intercept. Okay, then they want, what you have to know from this lesson, the last thing you have to know is the arms of the graph. Are these arms of the graph rising or falling? So the left arm of this graph is rising. The right arm of this graph is falling, right? And you're indicating that with your arrowheads anyways. The degree of this polynomial is a third degree polynomial, so it is an odd degree. And the leading coefficient of this polynomial is negative. What's going to happen in the next 2 lessons is there's going to be patterns that polynomials will follow. So all even polynomials will have the same type of picture. All odd polynomials will follow certain patterns, and that will be the next lesson. For this lesson, you just have to be able to look at arms, answer rising or falling, odd, even, negative, or positive is what you need to be able to answer for this lesson. That is it. There's only 3 questions in this in the workbook for this lesson. What I want you to do, I don't want you to do all of them. So 1 is going to be a lot of work. So I want you to do E to J, because you're basically punching all these polynomials into your calculator. You're looking at your table of values and you're doing little sketches. So E to J for number 1, I want you to do 3 different polynomials in number 2, A, B, and C. And then you will do number 3, which is answering the even, odd, and the arms rising or falling. Okay. There are no podcasts for this lesson. The podcast for graphing, I will give you your next class. So after we finish lesson 8 is what I will do. Okay, I'm just going to stop the recording.